back on what I'd like to think about was the architecture dream team. And he was ahead of the project that actually developed the ATAM, which many of us know and love. And he was co-author of 2 of our seminal books in software architecture. So Rick has an interest right now in security, and he's going to think about security, which seems to be on everybody's hot list, from an architecture perspective.
Thank you. So I guess this qualifies as, and now for something completely different. So thanks, Linda. What I'll be talking about today is really some early research and some early results into thinking about, as Linda said, architectural approaches to security. And so you might ask, well, as compared to what? Security has many dimensions, and addressing security properly in a project, in a system, requires consideration of coding, of policies, of operations, of physical access to resources. But it also has implications for design. But most of the effort today goes into coding. And I think this is for largely historical reasons. But we were interested in exploring the degree to which you can get benefits over and above coding. I'm not saying coding's unimportant. Clearly, you need to code using secure practices. You need to review the code that you're using. But what are the benefits that you can get from an architectural approach to security? So our claim is that, I should say that this is joint work with Jungwoo Ryo and Humberto Cervantes, both of whom are sitting to your right in the front row. So our claim is that secure coding is not enough. And so you, being good skeptics, might ask, well, why? Why isn't it enough? We've been coding for years, and our systems are pretty secure, kind of, sort of. So, well, one problem is that security is a weakest link phenomenon. That's to say, if your system is 99% modifiable, however you want to quantify that, then 99% of the modifications are going to be easy to do and 1% will be difficult to do. But if your system is 99% secure, assuming someone can find and exploit that bug, it's all not secure. Once they're in, and they have access to everything, and your security is binary. It's all or nothing. It's broken. Another reason why we think secure coding isn't enough is that secure coding practices are expensive. So if you've ever been through security reviews, security assurance, security qualification, these things take a long time. They cost a lot of money. They add a lot of time to project schedules. And so we think that there's at least some leverage to be gained by taking an architectural approach to security. And what we mean by that is the use of security frameworks. It doesn't have to be a commercial framework, although in practice it typically is. In the examples, the case studies that I'll be showing you, it could be that you've got your own security layer that you've built into your layered architecture, for example. But the point is that a security framework or security layer encodes best practices and helps to ensure that you are doing things the same way ubiquitously throughout a project, resulting in gains, as we will demonstrate, in both the security of the system as well as the efficiency of your effort. So what's the evidence for these claims, these bold claims? Well, until now, I think nothing. So we're going to provide what we think is the first pieces of evidence. And I'll stress first pieces. We've got 3 case studies that we've done, and we're looking for more. And what we wanted to do in these case studies is look at the implications of, the effects of using a security framework on both system quality, as measured by the number of vulnerabilities that a system evidences, and development efficiency. How expensive is it to create, maintain, modify the system, and specifically how much of the overall development effort is going into security stuff. So when we think about architecture, there are three related concepts that we, as architects, at least in the SEI school of thinking, there's three related concepts that we think about. There's tactics, and tactics, hopefully I don't need to explain to the majority of you, are fundamental building blocks of design. They're the fundamental design primitives, the options that an architect has at his or her disposal. Tactics are typically realized by or instantiated by or combined into patterns, and again, hopefully I don't have to say much about patterns. And tactics and patterns are realized in frameworks. And this is something that's gotten a lot less attention, but very few designers design from these conceptual primitives, or at least design from these conceptual primitives alone. An architect in the real world frequently starts off, or at least quite early in the design process, makes framework technology choices, and then has to wrap those, modify those, ameliorate those by choices of patterns and tactics. So these concepts apply to any quality attribute. They could help you with your availability or your testability or whatever, but here we're going to focus on security, and in particular, we're going to use the security tactics that were cataloged in the third edition of Software Architecture and Practice, which has been out for about, what, a year and a half now. And this is a little picture of the security tactics hierarchy that we presented in that book. And the nice thing about tactics is that they provide a design vocabulary. And we can use this in design, we can use this in analysis. So an architect thinking about security has to think about, well, how am I going to detect that an attack has occurred or is occurring? Perhaps there's a denial of service attack occurring. Or perhaps there's a man-in-the-middle attack, and I would detect that by noticing some message delays. Once I've decided that I'm being attacked, can I resist that attack? Can I limit my exposure to damage? Can I limit access to the system or to portions of the system, critical resources within the system? Can I authorize and authenticate actors or identify actors? Given that I have perhaps not completely successfully resisted an attack, can I react to an attack? Can I lock down resources? Can I revoke access? Can I notify people and send the troops in running? And again, given that I probably am not always going to be successful at any of those first three things, how do I recover from attacks? Can I maintain an audit trail so I can figure out who did what and go and repair the damage? Can I restore resources that have been corrupted or compromised, or at least notify people that their credit card data has been stolen, to use a relevant example? So tactics provide a vocabulary for the designer and for the analyst, but they're fairly abstract. And so how do we actually go about realizing these relatively abstract design intents or design goals? Well, one answer is that we can use security patterns. There have been security patterns published for more than a decade, books of them, websites full of them. And patterns are good, patterns are great, but there are well-known problems with patterns, with implementing them, maintaining them, combining them. Ask me after the talk if you want to. That's a whole different talk, and I can't go into the problems with those now, but again, ask me questions about that after the talk. I'm happy to bend your ear about that. Suffice to say that patterns by themselves have their own set of problems. They're great, I love them, but they're not by themselves a really scalable solution. So my claim is that frameworks are what architects are comfortable with, familiar with, focus on, and they realize patterns and they realize tactics. A framework is a reusable chunk of functionality that addresses some functional domain or quality attribute concern It's reusable across a broad range of applications. And there are lots of examples of frameworks for different functions, for different quality attributes. So there are security frameworks, Spring Security, ZK, Zen Framework, PHPSec. Some of them are Java only or PHP only, and so forth. And they're not a panacea, of course. Nothing is in software engineering, right? Whenever I teach software engineering or software architecture, I always say that the most important thing we have to keep saying to ourselves is, it depends. So frameworks can increase productivity, but they have some cost. There's a steep learning curve typically in frameworks. People are worried about the lock-in that's associated with frameworks. What happens if that technology gets dropped, isn't supported, turns out to have fatal flaws, doesn't evolve in the direction that I like? Okay, so given those underpinnings, let's take a look at our case studies. And what we wanted to do in these case studies is understand how the architects of each of these three systems approach security. What did they think about? What did they do? And then, looking at the different design approaches that I'll sketch, how did these approaches perform? And by perform, I mean, how expensive was it? How much of project resources went into keeping the system at whatever level of security they managed to achieve? And what was that level of security? How many vulnerabilities did these systems exhibit? So, sorry that this is a little bit cut off, but there are three, in the three case studies, oh, you can zoom in for me?
We're a room full of system architects, but none of us know how to solve it.
Thank you. That's amazing. How did you do that? So 3 case studies. You can see I'm a theorist. The first case study, we dealt with a company called Code One. And Code One is the creator of a security framework. They're a Korean company. And the system that we looked at, we're calling Acme. We're not allowed to say what the actual name or the customer of this system was. But this system existed. It had no security to speak of when it was built. Code One came in and applied their security framework to the system. So we speak about the Acme system in before and after states, before the use of the Code One security framework and after. The second system was built by QuarkSoft. If you attended Humberto's talk yesterday morning, where he talked about the architecture and the pre-sales process, he talked about his experiences with QuarkSoft. They're a big software consulting company based in Mexico City. And the system we looked at was an internal system. It was used within QuarkSoft for project management. And they used 2 frameworks to address security, ZK and Spring Security. And finally, the third system we looked at was an open source electronic medical records system called OpenEMR. The system was written in PHP. They used no security framework whatsoever. And we've been fortunate that we developed personal relationships with the architects of all 3 systems, so they were willing to work with us and answer our questions. So what we did is that we interviewed the architect, and we asked them, what did you do about security? How did you approach it? What techniques, strategies, tools, and so forth did you use? How big was your system, and how hard was it? How much effort did you expend on security? Then we scanned the system, and we used AppScan, which is a commercial scanning tool from IBM. And we used this as our gold standard for how secure the system was. And I realized that you can quibble. There are other scanners out there. Not all scanners will give you exactly the same results. But this was at least one benchmark that we felt was reasonable to use. And our goal here was to understand the trade-off space. What are the costs and benefits of the different approaches to security? And we outlined different levels of framework adoption. And I'll explain that in a minute. OK, so in our interview, the interview took most of the time, in fact, in these case studies. We asked the architect, what were your drivers in building this system? So was security even important to you? And we got various different answers with respect to that. The second part took most of the time. And here we asked, what are the approaches that you took to address this quality attribute? And what we did was we took the security tactics hierarchy, and for every security tactic, we turned that into a question. So we said, do you detect message delay? Do you detect a denial of service attack? How do you and how do you authenticate actors or authorize actors or maintain an audit trail or whatever it is? And in some cases, the architect would say, we don't do that. And in other cases, we'd say, yes, we do that, but it's entirely handcrafted, or we use the blah, blah framework, and we use it uniformly throughout our system. This, by itself, was a pretty interesting research output, because we discovered that the tactics make a really efficient way to interview an architect and get very quick insight into the approaches to address a quality attribute within a system. And since then, we've started doing other interviews with other architects on other systems, looking at other quality attributes. And we found this is really good, actually, way of getting very quick insight into a system, into its architectural strengths and weaknesses. That's another talk. Just wanted to make a little plug for that. We also asked the architect, how do you reason about the trade-offs? Everything in engineering is about trade-offs. So if you're going to spend more effort on security, maybe it means you're able to spend less effort on functionality or on availability or on something else that's important to you. Let's say you've got a framework or you've got a set of rules, coding standards, practices that you follow, or a layering that you've described. How do you ensure that your programmers actually do that? Is it through tooling? Is it through inspections? Is it through ball and chain? And then, this question that I've referred to already, estimate for us, please, what amount of total project effort goes into security, either with or without a framework. And then we also had a kind of open discussion after that. And I don't expect you to read all this, but we cataloged for each of the tactics the answers that the architects gave to us. So for example, do you detect message delays? Well, this is covered by ZK. So when a session's created in ZK, there are many short-lived objects created. Each one is a UID, and the UID is blah, 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 blah. So there's a little story that's told about how they use this framework. How do you verify message integrity? Well, this is covered by ZK. How do you authorize actors? That's covered by Spring Security. How do you ensure that default settings are not changed? Well, we don't do that. Right? So there were some cases where we didn't think about that. We don't do it. It's not important to us. And other cases where perhaps we do it by hand. And other cases where, yes, we simply invoke this service from the framework. Then we collected metrics. As I said, we ran AppScan against each of these instances of the systems, and AppScan spits out a report saying how many high, medium, low, and informational vulnerabilities. We measured the size of each application using commercial or open source tools. And the interviewees, the architects, estimated effort for us. OK, so what we ended up getting, and this was fortuitous, is 3 different security approaches if we consider the degree of adoption of frameworks. We had full adoption, and this was the QuarkSoft example. They started off from day one creating the system with security in mind. In fact, security wasn't one of the primary drivers of the system, but it was considered during the architecting process, and the frameworks were chosen that aided in that design. There was partial adoption. Acme started off without using a framework. At some point, they decided, we're having problems with security. And they got Code 1 people in, and they did a refactoring and adopted that framework. And OpenEMR did not use any security framework whatsoever. So any security that they did, when we interviewed them about how do you deal with SQL injection, how do you deal with cross-site scripting, that kind of thing, it was all via programming practices, inspections, finding bugs and fixing them. So entirely handmade. And that was also the case for the Acme system in its before state. Here's our results. And again, sorry for the horrible eye chart, but I will just highlight a few features of these results. For each system, we classified it as no adoption, partial adoption, full adoption, or no adoption. Here's the language of implementation, the size. Here's the AppScan results. So Acme before had 154 high-level vulnerabilities and 50 medium severity vulnerabilities. Acme after had 0 and 25. QuarkSoft had, amazingly enough, 0 and 0. AppScan, in fact, the people who ran AppScan said they had never seen a result that good, people who ran it for us. And OpenEMR had a moderate number of high and medium severity vulnerabilities. Also, we cataloged how many tactics each of these projects addressed. How many of the security tactics, how many security things were the architects worried about? And again, you can see that Acme after and the QuarkSoft system had reasonably high coverage, 12 and 13 out of the 17 tactics. OpenEMR and Acme before had relatively low coverage. And then finally, the effort. For the OpenEMR, which didn't use security framework, or Acme before, in both cases, they claimed that 20% of overall project effort went into security. In QuarkSoft, the architect estimated that 3% of project effort went into security, but it would have been 30%, and this was just based on his gut feeling about similar projects that they had done. It would have been 30% without using the framework, which is reasonably close to the estimates of the other architects regarding the amount of effort without a security framework. And Acme after was at 10% of total project effort. So what do we conclude from this? Well, certainly in terms of security, as measured by AppScan, 2 thumbs up for using a framework. You get 0 high-level vulnerabilities and some medium severity vulnerabilities, but 0 high level, which is pretty cool. And what we see is full adoption, relatively low effort. No adoption, relatively high effort. It's like Goldilocks and the Three Bears. And the middle one was, not surprisingly, in the middle. So based on this small, idiosyncratic, it's true, set of case studies, we think that there's already some compelling early evidence for the adoption of security frameworks, for this notion of full adoption. And why is this? Well, it shouldn't be a big surprise. It's going to be easier, cheaper, to build a system with these frameworks from the start than adding it afterwards. Partial adoption, however, is probably more common, probably much more common than full adoption. And I think this is because most developers worry about functionality first. That's what they're paid to deliver. That's what they're focused on. That's they're domain experts in. And then they worry about security and other qualities, performance and availability and so forth later. This is not the way that they tend to think. So why do we think it's best to address security via frameworks? Or maybe, let me broaden that, to take an architecture-first approach to security? Well, most application developers aren't security experts. They're experts in their domain. And so it is likely the case that even with the best of intentions, they're not going to get security right. It's subtle. Even if they were experienced, expert programmers, experts in secure coding, it's generally considered best practices that you don't write your own security controls. So give that to somebody else. Give it to another group in the company, put it in a layer, and make that someone else's business. Also, using frameworks increases the likelihood that security controls will be applied uniformly, consistently, And this is the same argument that we make for reuse. It's the same argument we make for product lines. You focus that functionality in one area, you get it right, you reuse it over and over again. It gets much more heavily tested because it's reused than it would be if it was simply done case by case by a programmer. And therefore, you free up developer time for working on application logic, which is probably what they like to do anyway, and probably what they're good at, and not worrying about security, which increases their overall productivity. So the final word is that, as I said, this is early work. We've just done 3 case studies. We're actively looking for other case studies. So if you have a case study that you'd like to do with us, please come and talk to any of the 3 of us at the break, and we'd love to talk to you. All that is required is that we get to interview the architect, and we get to run a scanner like AppScan on the system. So I'm happy to take questions now. Thank you.
Yeah, I was wondering if your studies have any sort of a breakdown into the areas of where the security vulnerabilities are, because that can make a great deal of difference. For example, the developer's use of a lag prepared statements is just typically a pattern. If they don't do it once, they use it everywhere. Whereas, so by just making that one change, you get a lot of bang for the buck. Yep. Considering that PHP application, considering that this tendency of security, which is the developer did not do a terribly bad job on that. But anyway, so what I was getting at, I guess, is what made ZK Spring Security so much better than X or Y? Where were the areas of vulnerability?
So I wouldn't claim that ZK and Spring Security were better than anything else. I think it was that they were adopted early and uniformly. In the example of the OpenEMR system, a lot of their vulnerabilities were SQL injections. Do you remember any other broad class of vulnerabilities that we found? Cross-site scripting.
Quite a few low-level security issues. There were actually, in terms of the numbers, there were a lot of vulnerabilities.
Yeah.
They fall in.
Something about ZK and Spring Security. Well, as Rick said, these frameworks, the architect didn't choose them, especially ZK, because of security. We wanted something for the presentation layer.
Right.
So it was really attractive and all that. But after we investigated, we realized that the combination, ZK is an open source framework. There's like a paying version. And when you take that paying version, which is the one he took, it combines really well with Spring Security and gives claim industrial grade security. So it was more like a serendipitous choice that gave these results, and that was pretty surprising.
Yeah, a question. Security seems to me to be one of those kind of moving targets. Something gets addressed and something new gets discovered, and then it gets addressed. And I'm just wondering, related to the framework piece here, because I can imagine it could go either way. Did you have any sense, based on the data, or maybe you can extrapolate from this, you were looking at 3 different applications at a particular point in time. When you get those estimates about 20% versus the 3% and the 10%, was that likely over a period of time where maybe that framework was installed and then upgrades were made as new security vulnerabilities were addressed in the frameworks? Or was it more a case of this was sort of like maybe they got one cut of the framework and go on top of it, so that maybe in the future, if that framework was going to continue to evolve, and maybe they'd see even more benefits in using the framework versus doing it themselves?
So we were fortunate in having an ongoing relationship with all 3 architects, and we've maintained discussions with all of them. And I think that the numbers in terms of the level of effort have stayed relatively stable. We haven't redone the scans, but we could do so. But certainly what we're seeing is that the levels of security appear to be comparable. So we're not looking at just a snapshot, although I've only presented a snapshot. It seems like these are robust trends. Did that answer your question?
Yeah, that
Okay.
Yes.
Yeah, you listed tactics. Was it holistic? My question was, when you did these 3 case studies, did you find any additional tactics that popped up that you kind of called out that you weren't looking at?
We did not, but I never claim that the list of tactics is complete, just like I would never claim that a patterns repository is complete. However, JR and I had a study that we did over a couple of years ago where we looked at patterns from the patterns catalogs and tried to say what tactics are behind each of those patterns. And we used that to slightly amend the tactics hierarchy to reach its current state. But we haven't made any wholesale changes to it since then. So it's been pretty stable. And that tends to be the case with tactics in general. They're pretty stable.
I'm going to keep my questions to the break because we have a 2:45